Algebra 1, Lesson 6-6, Systems of Linear Inequalities. Learning targets. I will be able to solve systems of linear inequalities by graphing and model real-world situations using systems of linear inequalities. A system of linear inequalities. Two or more linear inequalities. The solution of a system of inequalities. The set of all ordered pairs xy that make both linear inequalities true. We represent this as an overlap of two shaded regions. Example 1, graphing a system of inequalities. What is the graph of the system? So the first thing let's do is to number the inequalities. And then step 1, graph associated equations. So first we'll graph the first associated equation. We replace the inequality with the equal sign. We notice for the first equation we have slope-intercept form. Slope of 2 over 1 and a y-intercept of 3. Since we have a y-intercept at 3, we'll mark that on a graph in blue. And then we notice that the slope is 2 over 1, so we'll go up 2 and right 1. We note that the inequality does not have an equal sign, so we make a dashed associated line. We'll number that number 1. For number 2, we have 2x plus y greater than 2. Since that's in standard form, I will use the tic-tac-toe method. So substituting in x equals 0 in the equation 2x plus y equals 2. 2 times 0 is 0. 0 plus y is just y, so I have y equals 2, and so that's my y-intercept. I do the same thing, except now I'm going to let y equal 0. And I end up with 2x plus 0 equals 2, or 2x equals 2. Divide both sides by 2, and I get x equals 1. So I have an x-intercept at 1 and a y-intercept at 0, 2. Another dashed line because there's no equal sign. And that concludes step 1. We've graphed both lines, 1 and 2. And now we're going to do step 2, which is to test 0, 0 and shade where true. So the point 0, 0 means x equals 0 and y equals 0. So we substitute those points in for the variable in the inequality for number 1, which was y for number 1. Y is less than 2x minus 3. So when x and y are both 0, I get 0 less than 2 times 0 minus 3, or 0 less than negative 3. Since 0 is not less than 3, that's false. The graph of the line that we created splits the plane into two sides, a false side and a true side. Every point on one side is true or it's false. We test one. We tested 0, 0 for number 1. That was false. So from the standpoint of equation 1 and inequality 1, the lower side is false, the upper side is true, so we'll shade the upper side. So we've shaded the side that's true for inequality number 1, that's the true side. We'll do the same thing for inequality number 2. We'll substitute 0 for x and 0 for y. And 2x plus y is greater than 2. So I have 2 times 0 plus 0 greater than 2, or true 0 is greater than 2. That is false. So again, for the second inequality, 0, 0 side is false. And the left-hand side, hold on, take that back. So the side that contains 0, 0 is false. That's actually from the standpoint of inequality number 2. The left side, the right side is therefore going to be true. So we'll shade that area in red, and the overlap will be where it's true. And so you can see the slightly purplish quarter of the plane at the top is the solution of the system of inequalities. All right, example 2, graphing a system. What is the graph of the system? Again, we will number our inequalities just as before. We'll perform step 1, which is to graph the associated equations. And we'll start with the first associated equation in blue, number 1. So this equation is in slope-intercept form again. We have a rise over a run. We're going to go down 1 and right 1, and we have a y-intercept of 5. So we see the y-intercept for the associated equation 1 is at 5, and the slope tells us to go down 1 and right 1, and so we get the point here at 1, 4. And so the next thing we do is we connect the lines. Our original inequality has an equal sign, so we make it a solid line. So that is number 1. We'll do the exact same thing with the associated equation number 2. The associated equation number 2 is in standard form, so we'll use the tic-tac-toe method. So when we let x equal 0, we substitute that value into the equation, and we have negative 3 times 0 plus y equals negative 4, or y equals negative 4. Substituting y equals 0, we get negative 3x plus 0 equals negative 4. 0 plus anything is that number, so negative 3x equals negative 4. Divide both sides by negative 3, and I get x equals 4/3. It's a lot easier to use an approximate decimal for graphing, so that becomes approximately 1.3. So now I have my x and my y intercepts that I can graph for associated equation number 2. So we'll mark the y-intercept on the y-axis at negative 4, and then just past 1 is 1.3. And again, solid lines since we include the equal sign in the inequality. And so that is the associated equation number 2. Next is step 2, which is test 0, 0 and shade for both inequalities. So we have y is greater than or equal to negative x plus 5 for inequality number 1, and we're going to substitute 0 and 0 for x and y. So I have 0 greater than or equal to negative 0 plus 5, or 0 is greater than or equal to 5. That is not true. That is false. So we'll indicate the point that we just tested for the first inequality as false, and therefore the other side, the upper and right-hand side, will be true. And we'll shade that accordingly. So there's our shading for inequality number 1 in blue. Now we'll do the same thing for inequality number 2 in red. So we have negative 3x plus y less than or equal to negative 4. We substitute 0 in for both variables because that's what it means to test 0, 0. And I get negative 3 times 0 plus 0 is less than or equal to negative 4. But anything times 0 and plus 0 is 0. So we have 0 less than or equal to negative 4, which again is false. So the point that we tested from the standpoint of inequality 2 in red, hold on a moment, is false on the side with 0, 0 and true on the other side, because the line always breaks the plane into two sides. One is false and one is true for any given inequality. So we'll shade accordingly. We see that the overlapping region that's slightly purple, where red and blue overlap, is in fact the solution of the system of linear inequalities.